Hey everyone, I'm aware of the fact that this is a white background, but I am here. Woo. We're going to be doing a polyatomic ion foldable. This is Mr. Gilsdorf, by the way, in case you were confused or concerned. So we're going to be doing a polyatomic ions foldable, and we're going to start just by prepping the foldable. Basically, to get it prepped, you are going to need a blank sheet of paper, ideally computer paper, but if all you have is folder paper or whatever, you need a pen or a pencil and some scissors, okay? Or just the tenacity to rip it evenly. So let's give it a hamburger fold. So let's take the paper, fold it in half. Kind of limited by the camera here, so in case you are confused by it, I'll try to make it as clear as possible. Open it up to the full page, fold both pages or both sides of the paper into the center. Alright, so your paper should look like this now. Then give it, I'm going to make sure that my sides are creased very nicely to be sure I don't have any issues. Then crease it down. So give it a hamburger fold down. Then give it a second hamburger fold down. So ultimately what we want to see is when we open it back up to the main page, we should have 8 panels. Okay. Then we'll use our scissors to cut those 8 panels. Okay. And oh, that one went a little far. Oh well. So we have our 8 panels here. I'm going to make sure that I crease down the sides to be sure that I don't have any issues other than the one I just created when I ripped the paper. Alright, so I'm on the side that has the open panels. Let's go ahead and flip to the back side. Okay, and we're going to start up here at the top. And what we're going to do is we're going to first go ahead and identify what this is about. We are looking at polyatomic ions. Alright, let's go ahead and just break that word apart. Poly usually means many or multiple. Atomic means atom, obviously. And ions mean that we're dealing with something that is charged. Okay? So what we're basically talking about here is an ion made up of multiple atoms. So we're referring to an ion that has a charge, but has a charge because it has more than one atom in it. When you start seeing them, it'll make a little bit more sense. Alright, so let's look at the polyatomic ions. So we're going to go ahead and just do down the left-hand side, and we're going to start on the left. So the first one we're looking at is NH4 with a 1+ charge. NH4 with a 1+ charge. Open that panel. We're going to draw it over here on the left. So this is a nitrogen with 4 hydrogens attached to it, and I will be open and let you know that the way I'm drawing this is a covalent compound. This is a covalent structure, even though we're talking about ionic compounds. So this is a covalent structure. What makes it an ionic or a polyatomic ion is that all together it has misplaced an electron. So together, this nitrogen and all 4 of the hydrogens has a 1+ charge. And this substance is called ammonium. Ammonium is similar to ammonia, which you may have heard of. Ammonia is NH3, ammonium is NH4+. This forms a 1+ cation. So what's interesting about that is that it forms a cation. This is actually a cation. So in our previous lessons and our previous conversations, we've talked about how the cation is usually a metal. This is an exception. This substance together is a nitrogen and 4 hydrogens, all nonmetals, but together it forms a cation. So ionic compounds are really about the focus of a cation and an anion, not just a metal with a nonmetal. Okay? So let's look at a compound where it can be found as a cation. Cations always come first. NH4Cl, which is ammonium chloride. Alright, moving on to the next one. The next one is OH1 negative. Let's draw that. We have an O bonded to an H, and outside the brackets, we have a -1 charge because this substance has an extra electron or an extra negative charge. So that is why it overall is considered a polyatomic ion. It has more than one atom in it, but overall it has a -1 charge. No matter what, you're going to treat this thing as though it is an object with a -1 charge. Same thing here. You're going to treat this, even though it's all kinds of stuff going on in here, focus on the brackets. You are going to treat this object, NH4, as one thing with a +1 charge. Down here, OH treated as one thing with the -1 charge. This is called hydroxide. Easy to remember because like hydrogen, like oxygen, it's an O and an H, hydroxide. Forms a 1 negative anion. And let's just throw it in here with calcium. Okay. We talked about how when we put ions together, we need to make sure they balance out. Calcium forms a 2+ ion. Hydroxide is a 1 negative. So that means in order to balance that out, I need to have a second 1 negative to balance that out. That's why I have 2 copies of hydroxide. Calcium hydroxide. So remember, the goal here is always in ionic compounds to make sure that my charges add up ultimately to 0. So with a +2 charge on calcium, a hydroxide has -1. I need 2 hydroxides to satisfy the calcium, total of 0. All right, so moving on to the next one. This one you will become very familiar with and will accidentally memorize it. NO3 with a 1 negative charge. Open that. Nitrogen, oxygen, oxygen, oxygen. Overall, as a whole, has a 1 negative charge. Okay, so this particle as a whole has an extra electron. It is called nitrate. Nitrate is a 1 negative anion, meaning it's a negative ion. So if it forms a compound with something, just like with hydroxide, it's going to be found as the secondary substance. The first is always the cation, which is usually a metal or ammonium. All right, so with nitrate, let's just do sodium nitrate. Sodium has a 1+, nitrate has a 1-. They are good to go. Sodium nitrate. All right, moving on to the next one. The next one is PO4 with a -3 charge. Open that panel to the left-hand side. We have a phosphorus with 4 oxygens. And you actually, I don't know your background in bio, but when I taught bio, I mean, obviously, I was a chemistry person that taught bio, so I was like, yes, we need to know this. But phosphate groups are found in nucleic acids, so you may recall that. You may have seen this actual group. But either way, it is an object in itself that has a -3 charge, and it is called phosphate. Okay? That means, of course, that it is a -3 anion because it has a -3 charge. And let's put it together with aluminum phosphate. Okay? Aluminum phosphate. To confirm that this is correct, we need to check the charges. Phosphate has a 3 negative charge. Aluminum, if we look on our periodic table, has a 3 positive charge, so this one is good to go. All right, top right, we have SO4 2-. Open that panel. So just like phosphate, it's a sulfur in the center with 4 oxygens attached to it. Whoa. Oh well. Overall, it has a 2 negative charge. I'm going to hurt this paper. Doesn't even matter. You couldn't even see it. All right. So it's a sulfur with 4 oxygens attached, -2 charge on the entire thing. This substance is called sulfate. It's, of course, a -2 anion, or a 2 negative anion. And for sulfate, let's put it with potassium. Potassium and sulfate. Let's check the charges. Sulfate has a 2 negative, potassium has a 1 positive. Okay, so that means that I am not currently balanced at 0. I need to add a second potassium, another 1+, means K2SO4. Potassium sulfate. Okay, so potassium sulfate, in order to satisfy the sulfate and have the charge of ultimately 0, I need to have 2 potassiums to each sulfate. Next one, CO3 2 minus. So this thing is a carbon with 3 oxygens with an overall charge of -2. I put the brackets here because I want to remind you that anything inside the brackets, don't mess with that. Only worry about the charge on the outside. It's not your business to be walking up in here and saying that CO3 is not CO3, it's CO2 or CO4. Don't be messing with that. It's not your business. You only worry about the charge because that's what ionic compounds are worried about. We're worried about the ions. We're not worried about what that is. So this is referred to as carbonate when we name it. It is just like the previous, a -2 anion. And the most common is calcium carbonate. That is a very common compound. So calcium, well, carbonate we know just from looking above has a -2 charge. Calcium has a 2+ charge, so this one's good to go as CaCO3. Cation always comes first, anion second. Looking at the next one, HCO3 1 minus. Okay. All right, so it looks very similar to this one, although it has a hydrogen and 1 less negative charge. So we have carbonate with a hydrogen attached, and instead of having a 2 minus, it has a 1 minus charge. This is referred to as bicarbonate. 1 negative anion. And let's throw it with something. Let's do magnesium bicarbonate. Okay. What I usually do when I'm forming these ions or forming compounds, I write one of each. Maybe I'll need more, maybe I won't. We'll see. Magnesium has a 2+ charge, carbonate or bicarbonate has a 1 minus. So in order to make this satisfied, I need to add a second bicarbonate. I can't just put a 2 here because that is hydrogen, carbon, and 32 oxygens. That is far too many oxygens for that hydrogen and that carbon to manage. Okay, that is unacceptable. Plus, that wouldn't fix anything. That would just ruin what bicarbonate is. Bicarbonate is 3 oxygens, 1 hydrogen, 1 carbon. I can't just add 30 whatever, 29 or whatever. I don't want to do math. I can't just add a bunch of other oxygens onto this and say everything's fine. I need a second -1 charge. So that means I need 2 copies of bicarbonate. So just like in math, when I need to distribute something, I need to put it in parentheses so that I can distribute it. And this would be called magnesium bicarbonate. All right, last one. Last one looks scarier than it is, okay? The last one is C2H3O2 with a 1 minus charge, or it can be written as CH3COO with a 1 minus charge, okay? Now before you're like, look at these. These are identical. Okay, this is more of the structural formula of what it actually looks like. This is the more simplified version. Okay, so 2 carbons, 1, 2, 2 carbons. All right, 3 hydrogens, 3 hydrogens. That one seems all right. Oxygen 2, oxygen 2. It's exactly the same thing. Okay, so this is what it looks like. Carbon with 3 hydrogens attached. Okay, so hence why it's CH3. That's attached to another carbon that's double bonded to 1 oxygen, single bonded to another. I don't care that you remember that exactly. What I care about is that you don't touch anything inside those brackets and you only deal with the fact that it has a -1 charge. That is all that concerns you because it's an ionic compound. You're attempting to use this as an ion, so all that concerns us is the charge itself. We don't mess with any of that other stuff. So this thing is called acetate. It is, of course, a 1 negative anion. And let's do. Oh, let's make it serious. AlCH3COO. Okay. All right. this substance is aluminum acetate, but we're not done. I need to check my charges. 1 minus, aluminum has a 3 plus charge. I got that from the periodic table. This I got from here, obviously. 1 minus, 3 plus, that is not equal. So I need 2 more 1 minuses. So that means I need a total of 3 acetates. All right, parentheses, 3. Done. That's it. I need 3 copies of everything inside there. So notice I didn't add the 3 right here. I didn't change this and make it into something weird and add some 3. I didn't put a 3 over that, and I didn't do anything crazy. I just focused on the fact that this is 3 plus, this is 3 minus. I need for those to equal 0. So all I need to do, parentheses, I need 3 copies of it. All right, so make sure you have this in class tomorrow, either on folder paper or something else, because I will be checking it, and I want to see it as a foldable, okay? I want to see it because this is a great study tool for you to be able to study. All you really need to be able to study with these is recognizing the formula, the charge, being able to recognize what it's called, all right? You do not have to memorize these, so don't freak out, but have them committed to comfort at minimum. All right, see you guys in class next time.